Right, we have a couple of grade 8, grade 9 questions to do here, asked from me by a couple of my students. These are going to come up in the paper too in 2023, especially definitely these Surds questions will come up. Maybe not as hard as this one, but they will come up. Now, we've got these two brackets to multiply and equal that, and we've got E and F, which we don't know, but we do know they are positive integers, and we've got to find them. So the starting point is to multiply out this bracket here. So we'll do 5 root 2 times 3 root 2. And then we'll do the 5 root 2 times the e. Then we'll do minus e times 3 root 2. And then we've got minus e times plus e, which is minus e squared. And that's all going to equal f root 2 minus 6. Let's tidy up this side. So 5 times 3 is 15. Root 2 times root 2 is 2. 2 times 15 is 30. I'm just going to hold that to one side because I'm just going to do this third bit. I've got 5 root 2e and 3 root 2e, but take one away from the other. And I'm left with 2 root 2e. And then I had the 30 from here minus e squared. And you'll see why I've grouped those two together. And I'm going to put the root 2 in front of the f and the minus 6. And what you see, if we know that e and f are integers, then we know that this is an integer. Because e is an integer and integer squared is integer. If e is an integer, then this is going to be a surd, because integer times a surd gives me a surd. Okay, so the integer bit will equal the integer bit. The non-integer bit, the surd bit, will equal the surd bit. So we can make the yellow bits equal to each other, and we can make the green bits equal to each other. So on the yellow bit, we've got 2 root 2e must equal root 2f. And on the green bit, we've got 30 minus e squared must equal minus 6. So we can cancel out the root 2's here straight away. So we know that 2e must equal f. Now from here, we can get the e squared to this side and the 6 to this side. And we get 36 equals e squared. If you're doing this sort of level question, that should have been easy. Square root, we're told they're positive integers. So when I square root this, I know that e must equal 6. Technically, e equals minus 6 is also a solution to this, but because we were told it's a positive integer, then e must equal 6. So we know that if e equals 6, we know 2e equals f, so 2 times 6 must equal f. Therefore, f must equal 12. Right, a totally different question that's also likely to come up in paper 2 is to do with finding equations of straight lines and finding perpendiculars and parallels and all that sort of thing. So let's just plot this point. We know we've got A, B, and D, and we've got to find where C is. Now, if you go A, B, C, D, they always go round in that order. And we know that AB is going to be parallel to DC, but let's just plot them to see how it looks. Minus 4, 6, minus 4 and 6. Doesn't have to be exact. Okay, that's my A. And I've got 2, 3. 2, 3 is going to be around about here. And that's going to be my B. And I've got D is minus 1, 8 is going to be up there somewhere. And that's my D. So if we know that AB is parallel to DC, we know that C is somewhere over here. Okay? Or it could even be over here. All right? It all depends. But we know it has one line of symmetry, so it's not likely to be over here. So we know we're going to have a line of symmetry going down here. Okay? Now, we can find the equation of that line of symmetry because what we do know about the line of symmetry is perpendicular and it must go halfway between A and B. So let's find the midpoint of AB first to get our line of symmetry. So the midpoint of AB, this will equal the average of the points A and B. So minus 4 plus 2 over 2. And then the y's will be 6 plus 3 over 2. So we get minus 2 over 2, which is minus 1. And then we get the midpoints here is going to be 9 over 2. So we can also find the gradient of AB, and then we can find the perpendicular gradient of this. So the gradient of AB will equal the change in y. So the change in y from A to B for the y's is going to be minus 3. from A to B on the x's, we got from -4 to 6. That's minus a half. So therefore, implies the gradient of the perpendicular is equal to 2. Okay, because this is minus a half, reciprocal of that, and minus it gives me 2. So I know I'm going to go through this point, and I know I've got the point 2. Now, this seems to be quite a convoluted way to do this question, but as this is a question 25, then it is possibly the best way to do this question. Carrying on. So carrying on, we know that the equation of this line is going to be using the method of y minus y1 equals mx minus x1. We find the equation of this line is going to be y minus 9 over 2 equals gradient 2 times x minus 1, which is plus 1. So we're going to get y will equal, that's going to be 2x plus 2. Then I'm going to add another 4.5 here. So plus 2 plus 4.5 plus 6.5. And I get that equation there. I'm just going to scroll up slightly. Now, we also know that DC is parallel to this, and we know that D goes through -1/8. So I'm going to use this gradient for this line because it's parallel, and I'm going to use this point to the -1/8. So I'm going to do DC is going to be y minus, what was it? -1/8. So y minus 8 equals -1/2 x. Was that a -1? -1s plus 1. So I know that y will equal -1/2 x. That's going to be -1/2 plus an 8 gives me plus 7.5. So that's the equation of my line DC. And I've got my equation of this line. So I can find out where this line will intersect this line. So let's solve this to find out where these two lines intersect. And then double the distance d to this point will give me DC. So let's do this. So we get 2x plus 6.5 will equal -1/2 x plus 7.5. So these two equations are simultaneous equations. That's y equals and that's y equals. So this will equal this. And so therefore I get 3.5 x will equal, take 6.5 away from 7.5, I get 1. So x will equal 1 over 3.5, which is 2/7. It's not a very nice number, is it? So x equals 2/7. Therefore, we can find out y. Just want to check that. Okay, I did make a mistake. So it's easy to see, this didn't feel like a good answer because it's not a very nice number. And I realised -1/2 plus 2 is going to be 2.5. It's always, when you feel something's not right, just to have a quick pause just to check what's going on. So we've got 1 over 2.5, which is the same as 2/5, which is the same as 0.4, which is a much nicer number. Okay, so if x equals 0.4, then the y value is going to be equal to -1/2 0.4, which is -0.25. So we're going to get 7.2. Oh, not 7.2, 7.3. And we can check that in the other one. So we get 0.4 times 2 is 0.8. Add that onto 6.5 and we get 7.3. So we know that we have got, let's call this point M. And so we know that D is at -1/8. Okay. And we know that M is at 0.4, 7.3. And then we got C, and we know that M's the midpoint. So if we've gone from -1 to 0.4, we just need to put on another 1.6 to this to get to C, because that distance is 1.6 in the x. So add on 1.6 in the x, and we get 2. We know we've gone -0.7 on this one, so go -0.7 on that one, and we'll get 6.6 is our value for here for C. If you take 0.7, so we've gone, what was it, -1.6, and then we got, no, it's plus 1.6 and minus 0.7. So do that again, plus 1.6 minus 0.7. Here And we get this answer for C. And what we notice with this is actually I've gone too far. I've actually solved more than I need to solve. Okay. The question actually asked, the line of symmetry CD intersects at the point E. This is my point E. M is equal to E. So I found E. I didn't need to find C. I went one step further. So my value for E must be equal to 0.473. So there you go. So when you finish your question, good point is always to go back and just check you've actually answered the question you're supposed to answer. And I'm going to leave these mistakes in this video because actually all the mistakes I've made are quite useful ones for you to learn from as to what can go wrong in the exam and how to spot them and how to correct them.